Hi, everybody. Thank you for joining us today. We're just going to give it a couple of minutes just to give everybody who's registered a chance to join the webinar, and then we'll start just after, just in just a couple of minutes. If you're not seeing anything at the moment, just please click on the big triangle play button in the middle of your screen, and you should see something. We're also recording this webinar, so if you do have to drop off for any reason, it will be available on the definitely on the Bluestream website, and I'm sure it'll be available from the Flow website, and we'll email around a link to everybody who's registered for the webinar so they can view it afterwards as well. So I think that what we'll do is we'll start this going. I'm very pleased to say today I'm joined by PD van der Vee from Flow Document Solutions, and I'll let PD introduce himself. Just going to give a quick introduction of myself, a little bit about documentation 4, which is a term that Bluestream used to explain and discuss where we need to go with technical documentation today, and then hand over to PD. He's going to talk to you about the stuff that they've done and give some real life examples of how you can push this DITA technology to start delivering more and more things as we go forward. So you have the opportunity to ask questions. Put some questions in the chat. We'll reach those at the end of the session. Try and answer as many as possible. If you've got questions after that, then just reach out with emails to us both, and we'll endeavour to answer your questions. So for those of you that don't know me, my name's Rick Page. I do work for Bluestream. Bluestream is a CCMS vendor. I've been working in structured content and structured documentation for many years now across multiple markets and all over the world. It's been interesting to see things come and develop and move on, really. So Bluestream, as I said, I work for Bluestream. Bluestream is an independent Canadian company founded in Vancouver. Been working in XML for many years. Our prime product is a component content management system called XDocs. We're a bit different from, I used to say we're different from the main competitors in so much as we're champions of open standards. We like our open standards. We support pure DITA, whereas some other companies out there can't support pure DITA. They do some things behind the scenes to make it work. And we've not been taken over by anybody, so that's also unique at this current moment in time. And we cross all industries, but we do a lot of work with manufacturing companies, and that's really what we're talking about today. Now, if you listen to Germany, really was the original developer. This concept of Industry 4 or smart manufacturing, a more advanced approach to manufacturing with greater automation, more interaction between software systems and machines, and now many other countries and companies are adopting this same process. Like I said, it came out of Germany originally, and it's sometimes you'll see it referred to as a smart factory or smart engineering, but it's underpinned by 4 clear design principles. So originally, the idea, the first principle was all around interconnection. So to improve the effectiveness and the efficiency of machines by using wireless technology and the IoT or IIoT, Internet of Things, Industrial Internet of Things, to connect machinery to sensors, to applications and other devices responsible for the processes. The second principle is about information transparency. So if you start putting more and more of these sensors and linking systems together, you collect a lot more data, but that data, you can use that to improve the processes. You can understand why things are going wrong. And there is a massive amount of data now being collected by machines. One of my favorite facts, and this isn't within a factory, but if you look at Pratt and Whitney, who are an aircraft engine manufacturer, they've got they call it a geared turbofan engine, but actually is fitted with, hard to believe, 5,000 sensors, and that can actually generate 10 gigabytes of data each second that it's running. I'm not sure how you could ever analyze that, but it's an amazing fact. Now, the third principle is all around decentralized decisions. So interconnection and information transparency allows operators to make decisions within the production line and outside. And if you're getting information for everywhere, you can make much better decisions if things need to change or you need to stop production or make adjustments to it. And then the last principle is this idea around technical assistant. The original documentation talked about in changing the role of humans from an operator of a machine to a problem solver and a decision maker. And so in order to do that, and part of what we're going to show you today is you need to give them that information in a clear and easily understood way. Now, whilst we've got to Industry 4, we've also gone through a bit of a documentation revolution over the years as well. So we started life, these are my numbers, but I think the world will adopt them at some point. So documentation 1 was really when we first started writing. You can go, it was more than 3,000 years ago. Lots of people will dispute exactly where and how it started. Most people would say it's around what at that time was Mesopotamia. But that was the first thing when people started putting information that other people see and acknowledge. Documentation 2, printing, really. Now, the Chinese did invent woodblock printing, but Gutenberg's press was the first press that could produce, had movable type, and was able to produce documents again and again and again and again. Not particularly quickly, in all honesty, but it did work. Unfortunately, it didn't make Gutenberg any money. He actually died in poverty. But the idea was copied, and actually eventually, from a historical perspective, printers moved to the ports, and then the documents that they were printing were sold to ships captains who started a very early version of Amazon and buying books and taking them around the world with them. Now, documentation 3 is really, we reached this on-screen display point. Now, I remember teletext on televisions where you could actually look things up on TV. And that's where multiple people are seeing the same information and reading it at the same time. So now with the growth of the internet, 1.2 billion pages on the internet at last count, I think. Although if that was last count, it's probably gone up since then. But now lots and lots of people can share and the same information and read the same information at the same time. So that's really was where documentation 3. But now we're at this idea of documentation 4. And now why do I think we need documentation 4? Well, I think if you're looking at industry 4 and a smart factory, you need the documentation to support this much better than it has done historically. Now, manufacturers face some real challenges that aren't faced within the software industry, for example. Now, as machines get more complicated and have more variations with multiple pricing differentiators and various other bits, and you need lots of complicated pre-sales documentation. People aren't going to buy $200,000 worth of machine or equipment without actually investigating things fully. So you need to get all this pre-sales documentation, and it needs to reflect what it is that you're trying to sell. And then when it turns into an order, you've got the issue of the need to provide lots of different types of documentation. So you need to have the installation guides and the user guides, maintenance schedules, parts lists. And then on top of that, if you are in manufacturing, you are building machines and you're shipping those all over the world. Within Europe, we've got 27 languages that you may need to produce all that documentation in. Then you need to make it available online, because you can't just give people massive, great big folders and books generated from PDF, because it's just unsustainable. If an engineer is doing maintenance, they can't actually carry, well, they don't want to carry massive amount of paper around, and paper gets out of date. You can't control whether or not they're carrying the latest documentation. So it's got to be available online, or ideally available at the machine itself. But also it needs to be updated. Things change. These machines are going to last for a long time, and in that time they're going to go through updates. They're going to be modified. They may get sold and passed to somebody else. Someone else may do further modifications. The documentation has to live as long as the machine. And the machines, I started my life in engineering, designing process plant, and some of that process plant is still available today. And I've already told you I've been involved in software and documentation for more than 20 years. So you can imagine quite how old some of that machinery is, but it's still out there. It's still being sold and passed on. And there should be documentation that goes with it. I know that for a fact there's not, because it was never something that we did back at that time very well. And then you've got the fact that we've got this content is in different places. So it's not just stored in the CCMS, or it's just not in SharePoint. You've got content in a CAD system, you've got PLM systems, ERP systems, and everything. And if you're assembling this documentation that is complicated by hand, it then becomes very time consuming. And anything that you're doing manually, not only does it take long, there's a chance that errors are going to creep in. And errors in documentation are dangerous because they can lead to very serious mistakes. And as I mentioned earlier, if you're a field engineer, you need to be able to find that information quickly in order to identify what's wrong, order a replacement part. All of this needs doing. And that's where sort of documentation 4 is needed. It's needed to support manufacturing, and it's about having machine-specific documentation, evolving content, and then this intelligent content that understands what it is. So you need to bring metadata into it so you can find the content easily and find out what you're doing. And if anyone's heard me talk about this previously, I apologise for repeating this, but I hate poor documentation. We see a lot of poor documentation out there, and I always bring up an example. I bought quite an expensive razor from Philips, and having spent, I think it was about $200. It was quite expensive, but I had a piece of paper, and this is actually the scan of the paper that they give you with this, and this thing, quite expensive razor. You've got to find the code, which isn't actually there. It's actually around the back, and then work out which of these applies to it. It also comes with a cleaning system, which you've got to work out which one you've got because they have different functions. Now, I actually went and looked. So that is the model of my razor, which means this is irrelevant. And the only difference between these two cleaning systems is there's one extra light there. And it's to show you how hard it is to work out which part you've got. I just took a photograph of it. So as you can see, you can't tell whether that's got 3 or 4 sections down there because it's completely black and it's lit from behind. So it's really hard to work out how things work, and that's just a simple consumer product. The guy I used came back for my toothbrush. I don't like the documentation Philips produced, but the products are quite good. So I did go back and buy some more, but it's no better. They're just doing very poor documentation. So this documentation for idea is, can we link the content to other systems? Can we join it up? Can we bring content in from other places? We then localize the content, and then it's this intelligent delivery out to the device. And coupled with that, it's the management of this moving forward. So throughout the product's life cycle, how do we manage that? Now, from a Bluestream perspective, our solution, we've developed what we call our manufacturing suite. This is a little bit of a plug, so I apologize, but I feel I should do. And what the manufacturing suite does is it lets you connect to other manufacturing systems and ingest information from those systems. We're bringing together these other systems. We can import a bill of material from an ERP system. We can import drawings, and we can start building things like our illustrated parts catalog, so we can auto-generate some of this documentation and maintain it in a more intelligent way. Now, this isn't here to just talk about this, but if you want to know more about what we can do in the manufacturing suite, please contact me after this, and we can go through that in a lot more detail. But from there, I'm going to pass over to PD Ann, who's going to take over from this point. Let me just stop sharing for a moment. And PD Ann, you should now be able to share your screen.
Okay, I'm about to do that. Okay. All right. Can everyone see my screen? I think so. Yes.
Yep, that's
okay. Cool.
Nice and clear.
Okay, so hello from me also. The case I want to present today is one about Picanol. But before I get into more detail about the IoT in action, I first want to tell something about the company I'm working for, and then let's just dive into the use case. So I'm working for Flow. It's a technical communication company based in Ghent, Belgium. I have 25 colleagues who do mainly technical writing, but we also give consulting and coaching in technical document and technical communication. And one part of that is giving training in structured authoring, information modeling like DIDA. We give training in technical writing, but also tools like Adobe FrameMaker, Oxygen XML author or training to publish XML to PDF with Miramo PDF. We help companies with their content strategy. For example, when they want to move from an unstructured way of working to structured information model, we can help them analyzing their current content. We can give them advice on choosing the correct and right tools, and we also support them with the implementation and coaching afterwards. And we also do template design, like, for example, from XML to PDF or from XML to HTML, or also create FrameMaker or Word templates if needed. You can find more information about the company itself at flowtime.be. So I'm Pieter Jan. I work as information architect for Flow. I have more than 10 years experience with DIDA. First couple of years was more in the background, working for a translation company and handling data translations. And since 5 years, I'm helping companies with the implementation of data. I do data coaching and style sheet design. And I also help people with. I also think it's very important that the user experience for technical writers is good. So I also try to help technical writers to get a good user experience with their tools. So one word about Picanol. So Picanol is a world player in weaving machines. They are active in more than 100 countries, and they have development and production in Ypres, Belgium. They also have an engineering and production in China. They have the fastest rapier and air weaving machine in the world, and currently more or less 2,600 weaving mills are using Picanol machines. And on today, their machines come with a human-machine interface. A human-machine interface, it's a dashboard that allows the operators to interact with the machine. And the idea was to make the technical documentation available for the operators on these machines. So before we explain the goal of the project in further detail, I just want to take you one step back to look at the situation where we started. Each loom, weaving machine, comes with a huge set of documentation. I think more or less 1,800 pages per language. And at Picanol, people noticed that this content was not used by the operators. And that's not the idea when you create the documentation, because you want the people to use it and minimize, for example, troubleshooting calls for your help desk team. Documentation from Picanol is a combination of mechanical and a software part, where the software part is updated on a regular basis. In the original setup, this updated documentation was not always available for the operators. And also, these operators at the machine, they are sometimes working in an offline environment. Wi-Fi is not available everywhere, so that was also something we should take into account. So the goal of our project was to make the documentation available for the operator at a tap of a button. When you are working at the machine and a problem arises, you want to go straight to the piece of content that describes your problem. You don't want to go through a complete manual. That's why there's a need of high granularity. And on top of that, you want all procedures to be written in a consistent and user-friendly way. So we're also living in a world of visual communication. So we use screenshots, images. You should, for example, be able to zoom in. And in our case, a manual in English is not sufficient for the operators who do not always speak the language. So at Picanol, we wanted it to be available in as many languages as possible. And last but not least, I mean, software updates on a regular basis, so it should be available also in the latest version. So our action plan was, first of all, we looked at the content itself. There was a digital transformation of the complete documentation set needed. We moved from unstructured environment, FrameMaker, to a structured environment, Theta XML. This made it possible to work with small components, fixed structures for each piece of content, and very important in this case, we could add unique metadata to the components. Metadata could be, for example, the version of the software it applies to, but also the machine, the kind of machine, and other information. And to manage all of these files in many languages and have a user-friendly way to handle the metadata, we needed a CCMS and at Picanol, and we decided to go with Bluestream Xdocs. So once we had a plan for our digital transformation and how we could make it happen, we also thought about, in the next step, how we could present it to the operators. So we decided to go for an offline knowledge base with a powerful search and available in multiple languages. It was very important that, for example, if you that the people could read their documentation in the language they are working on, or that was available on a machine. So, and also it should be updated. The documentation should be updated together with a software update. So the technical and a technical documentation couldn't do this on our own. We also needed close collaboration with the IT team that is responsible for the HMI. So as I told before, the technical communication team added metadata to their content. Now we had to map these metadata in a way that the HMI could interpret it correctly. And to do this, there were a couple of challenges. So we wanted to work with a context-sensitive help. So meaning that the operator just had to click on a button to go to the right piece of content. But we also needed to get the right documentation on the right loom. So there had to be a mechanism to check which version was installed already on the machine. And based on that, we could upload the right version of documentation. And an extra challenge was also we had to make sure that technical documentation didn't take too much disk space on the HMI. So this is still things we are working on and making better every day, but this is how it looks like today on a Picanol machine. So as you can see, people can just go to the technical documentation, scroll or move down and go to the piece of content they want. In this case, in this particular case, it's not context sensitive help, but it's how people can go from and go and search for their piece of documentation. So as a kind of feedback, we heard that the customers were happy with the result and having technical documentation on their HMI. So there were 2 follow-up projects so far. So we also wanted to make part of the documentation available for the operator via an icon drill down menu. And we also wanted to make troubleshooting information available for the operators. So the icon or the drill down menu manual is a case where operators don't always want to search for information. Sometimes they want to get to the right or the correct information via icons they know from the machine. So people just there's a certain hierarchy in these icons, and people get to the correct information with these icon drill down menu. Again, this is available in multiple languages, and this is how it looks like. So people can just click on a button. They recognize from the screen whenever the button on itself is not sufficient enough, we add some extra information next to it, and people can very easy go from one part of the manual to the other. So the last part is that today we also have troubleshooting information available on the Loom. Whenever there's a problem, and people at and the people at Picanol write content about it, write some information about it, eventually they will see it on the Loom. So to make this happen, we had an engineer, subject matter expert who is writing in DIDA right now. We are working with fixed templates to make it as easy as possible for non-technical writers. And it's the idea to have more engineers working with DIDA in the future. And for that, we are thinking about moving to online editing for the SMEs with the Bluestream Wex. But also this troubleshooting information is available right now for the operators. In this case, operators cannot search. They just get an HTML5 page with the instructions on how to solve or what they can do to solve their problem. So with this the last I have a next slide saying, so when you go back and see at the goals we set at the beginning of the project, I think we can say that today, thanks to the effort of the technical writing team, technical documentation team, and the HMI team from Picanol, we make documentation available for the operators at the top of a button. It's in small pieces of content. We try to do it in an as consistent way as possible, make it user-friendly in HTML5 output in many languages. It can vary from 14 to 16 languages, and it's also in the latest version. And also, I believe that the people at Picanol, they are happy with the result, because also the marketing team from Picanol, they promote their technical documentation on the HMI with some posts on LinkedIn. And with this last slide, I think I want to conclude my small use case. I don't know if anyone has any questions, I will be happy to answer them.
Thank you, Peter. And if you stop sharing your slide from your screen for a moment, and I will just put our contact details up there. We've not had any questions, but we are happy to take any if anyone wants to put any questions in there. Like I say, there are contact details. I'd like to thank PDM for taking time to share that with you. It's nice to sort of see the things that we've been talking about for over a year now at Bluestream actually coming to fruition, and companies are adopting this, sort of doing more with the technology, the ability for Picanol to push up regular updates out to their machines. You know, that's the sort of thing that we're talking about now. We're moving the documentation forward, and it makes the documentation more valuable. It's really important that people can see the benefit in the documentation. So I'm just seeing a few questions coming through. So just seeing one from Susan. Peter, can you see the questions or the question from Susan under chat? Or shall I just ask you it? That's easier. It says, are there code examples that show how the machine pulls the right content based on metadata?
So what we do is whenever we publish, we give a set of I think it's more or less 10 pieces of metadata we add to an XML file, and based on these metadata, we are sure that we upload the right version to the machine.
Excellent.
So, and actually, we add these we add these metadata to DTMUP, and based on that, we get all the information.
Brilliant. And another question just come in: how do you implement and maintain context sensitivity?
So I think we have very clear rules about the IDs, how IDs could look like, and we don't do this based on names of files or something like that. It's really based on metadata, and we map. There's a mapping between what technical documentation team does and what the HMI IT team can read, and with this mapping, we are again sure that everything goes fine.
Thank you.
I don't know if that answers the question. Okay.
Brilliant. Okay. Now, Pierre has just asked, do you have product variants and do you handle that with metadata?
Yes, there are also product variants, and yes, it's also handled with metadata. So it's for a technical documentation team at Picanol, whenever they write topics, they really have to define for which kind of product or variant they are writing, add the correct metadata. They also have to add information about whether it's mechanical or software, and based on all these metadata, we extract the correct information to get it on the machine.
That's brilliant. Thank you very much. And that's a nice message that the Tech Docs team at Picanol are very pleased to be working with you, Peter. So
yeah, thank you.
There's a nice to get a public acknowledgement of how well you've done that. I remember you showing it to me what you're doing when we're I think we were in America last year, and it's I was just wanting to get more people to see this. It's fantastic what you've done. So
it's not what I've done. It's not only what I've done. It's together with the people.
Yeah, I mean, as a team, but it's good tech. I like good tech. So it just leaves me to say thank you very much, everybody, for attending. Like I say, I'll send out a link to everybody with the recording on. I'll do that. That'll be tomorrow. So I need to do immediately now. But it just leaves me to just say thank PDM one more time for his help on this. And I hope to see you at some of our future presentations and at various events throughout 2023. There's a TCOM event happening in Stockholm next month, and another one in Copenhagen in September. So if you're in Europe, they're available, and there's what was DITA North America, but is now called Convex, is happening in Baltimore in April. So if you're at any of those events, I'm going to be at all of those. It'd be great to if you stop by our booth and say hello. So thank you very much. And with that, I'm going to finish this webinar. So goodbye.